वक्रतुंड महाकाय सूर्यकोटि समप्रभ निर्विघ्नं कुरु मे देव सर्वकार्येषु सर्वदा।
Hello and welcome to our comprehensive series on data engineering. I'm Sunil and I have been working in software development and data engineering over the last 15 years. In this video, we are going to explore the fundamentals of data engineering and setting the stage for your journey into this exciting and rapidly evolving field. This is the first video of the series and we are going to cover data engineering fundamentals. Let's start with the agenda. So we are going to cover what is data engineering life cycle, roles and responsibilities, importance of data engineering, current trends in data engineering, and then we are going to cover basic data engineering tasks using Python. So first things first, let's understand what exactly is data engineering. So at its core, data engineering is the art and science of designing, building, and maintaining the systems and infrastructures. So what kind of systems and infrastructures that a data engineer builds? Such kind of infrastructure that enable the collection, storage, processing, and analysis of large volumes of data. You can think of data engineers as the architects and builders of the data world. In the real world, architects design buildings and construction workers build the buildings based on those designs. Similarly, data engineers create the foundations and the structures that allow data scientists, data analysts, and business users to use data and extract valuable insights from it. So let's explore the data engineering life cycle. Data engineering life cycle typically consists of 5 main stages. The first one is data generation. Second one is data ingestion. Third one is data storage. Fourth one is data processing and transformation. And the fifth one is data serving. To understand these concepts, let's take a real world example. Imagine you're working for a large e-commerce company. Let's say you work for Flipkart or Amazon. So one of the first stages in these 5 stages is data generation. So this is where the story of the data begins. So in our Flipkart example, data is generated every second of every day. It's created when customers browse products on the website or mobile app. Data gets generated when they make purchase, leave reviews, or even when they interact with the customer service, isn't it? So each click, each purchase, and each review, all this generates a piece of data. Next comes data ingestion. This is where we collect and import data from various sources. Coming back to the example again, Flipkart. Flipkart might be ingesting data or the logs generated from its websites or mobile app interactions. And even the third-party logistics providers, right? They are connected with the third-party logistic providers. They do generate certain kind of data. So all these diverse data streams are brought together in this phase. Next, we have data storage. So once data gathering is completed, the next task is to store it efficiently. It's like organizing a massive library. Here we have many relational, here we may use relational databases or non-relational database depending on the use case and the type of data. Flipkart might use a combination of relational databases and data lake. Relational databases for transactional data and data lake for storing large volumes of unstructured data like customer clicks and all. You already know about relational databases. It stores data in rows and columns based on certain schema. A data lake is a system or say repository where data is stored in its natural format or the raw format, usually blobs or the files. You can think of unstructured files, logs, uh, audio, video, etc. Next one is data processing and transformation. This is where the magic happens. So raw data is cleaned, transformed, and prepared for analysis. Coming back to the example of Flipkart and Amazon, this stage might involve joining customer purchase data with the product information. Later on, we might need to calculate metrics like average order per value or prepare data for creating machine learning models that predict customer behavior. Finally, we have data serving. This is where the processed data is made available to the end users. Most of the organizations use dashboard to present data. Executive get access to the dashboard and they are able to view the required reports. Data can be also be served via APIs. For example, we may create certain endpoint to be used by the mobile application. Many times we do generate data sets for the downstream systems or the other stakeholders such as data scientists or analysts. They build predictive models. At this stage, the right data is served to the right people in the right format at the right time. Now that we have learned about the life cycle, let's deep dive into the roles and responsibilities of a data engineer. What does a data engineer do in day-to-day basis, or how does a day look like in the life of a data engineer? So to understand the roles and responsibilities, data engineers wear many hats, but their primary responsibilities include these 5 basic tasks. First one is designing and implementing data pipelines. Second one is ensuring data quality and consistency. Third one is optimizing data storage and retrieval. Fourth one is implementing data security and privacy measures. Fifth one is collaborating with data scientists, data analysts, and other stakeholders. Let's get into a bit deeper. So first of all, designing and implementing data pipelines. Data engineer often create a data pipeline. It may either be used for batch processing or stream processing based on the requirement and design. An example could be processing of real-time sales data from all over the world and updating the inventory levels. We can design it in such a way that it generates notification in case the stock of the product goes below a certain threshold. It's like having an assistant who will constantly monitor the system and update the entire inventory system and alert you in case the stock goes below certain threshold. Next one is ensuring data quality and consistency. This is very crucial. Data quality is very important. So data engineer needs to implement checks to ensure that data meets certain level of standard. For example, data engineer might need to apply checks to ensure the product price is always positive. We can't have items with the negative prices, right? They would make sure that email address etc are valid. We would also need a kind of check against duplicate order entries. Imagine you receive 2 iPhones in case the same order is processed twice without paying for the second order, right? So these are some of the things that needs to be taken care by data engineer. Third one is optimizing data storage and retrieval. Data is getting generated at such a speed that we need robust system to handle this humongous amount of data and the speed at which the data is getting generated. So in this case, storage optimization is required so that data can be retrieved faster, and at the same time large volumes of data can be saved without wasting storage. So the data optimization is pretty much required for the storage part. The fourth one is implementing data security and privacy measures. This is becoming increasingly important, especially with personal data protection bill. So data engineer needs to ensure that customer data is encrypted and only authorized data can decipher or access the data. Data engineer may implement different levels of security. Admin may have delete access for the data, and at the same time, other users may have no access to the data. It's the job of a data engineer to implement this robust security and privacy measures. Lastly, collaborating with data scientists and analysts. Let's say data scientist at Amazon wants to build a recommendation engine. You know, those systems that suggest products you might like based on your browsing history or based on your purchase history. Our data engineers will work closely with them, with data scientists, and ensure that they have access to the clean and relevant data so that they can predict this kind of systems. These responsibilities might seem overwhelming, but this is what makes data engineering so exciting and impactful. Every day, new challenges and opportunities, right? So it makes a real difference in how the business operates. Now, let's talk about why data engineering is so crucial in today's world. Everyone is talking about data engineering, data science, and all. So we'll like to understand the importance of data engineering. So the first and foremost, data engineering enables data-driven decision making. Companies like Flipkart and Amazon rely on data to make informed decision. Should we open a new fulfillment center in Pune? Should we open a new fulfillment center in Mumbai or Hyderabad? Which product should we promote during Diwali sale or Big Billion Day? These kind of questions we have, right? And this kind of question needs to be answered. So data engineers ensure that accurate and timely data is available to answer these questions. Secondly, data engineering is crucial for scaling business operations. As business grow, data gets piled up. A small shop might be able to manage with few spreadsheets, but what about a nationwide e-commerce platform, right? That requires a robust and scalable data systems. So data engineers build these systems and ensure that the systems can scale smoothly and can handle millions of orders. Third is data engineering enables advanced analytics and AI. The rise of machine learning and AI is not just hype, it is already transforming various industries, but these advanced applications need a solid foundation, right? It needs clean data. Data engineers do this groundwork and make it possible for data scientists to build recommendation systems, fraud detection algorithms, and much more. And the fourth one is data engineering plays very crucial role in compliance, right? In regulatory compliance. So with the increasing data privacy regulations worldwide, ensuring compliance is more important than ever. Data engineers implement the systems and processes that protect users' data and adhere to the compliance and regulations. Lastly, compliance competitive advantage. So data engineering provides a significant competitive advantage. In today's market, the ability to quickly derive insights from the data, that's the only difference, right, between the leading the market and then lagging behind. Data engineers make this possible. They give business the agility to respond to the market changes and customer needs in real time. I always say data engineers are the unsung heroes of the digital world. They are the ones working behind the scenes to make sure that the big billion day and like those are successful. So now that we have understood why data engineering is so crucial, let's take a look at some of the current trends in data engineering. First of all, the first on our list is cloud adoption. Many companies are moving their data and infrastructure to the cloud, and for a good reason. Cloud platforms offer scalability, and often companies are able to save cost when they migrate on-premises infrastructure to the cloud. They no longer need to bother about the maintenance of the servers or the infrastructures. Some of the major players like Amazon, AWS, Microsoft Azure, Google Cloud, they're all expanding their presence worldwide. This shift to the cloud is enabling business of all the sizes to leverage advanced data engineering. Startups have most of the infrastructures on the cloud. The second one is real-time processing. So we are seeing a growing demand for real-time processing. In today's world, waiting for overnight batch processing is not an option. This is especially true like e-commerce and finance. Imagine Flipkart or Amazon wants to update product recommendations in real time based on customers' purchase behavior. Banks or fintech firms might need to detect fraudulent transactions as soon as they happen. This trend is driving the adoption of technologies like Apache Kafka or Flink that excels at processing streaming data. Third on our list is data governance. There is an increased focus on data governance. Business are paying more attention to how they collect, store, and use the data. Data engineers are at the forefront of implementing these systems and process to ensure compliance. The fourth one is we are seeing continued focus on data, uh, big data technologies, but with a twist. While technologies like Hadoop and Spark continues to be important, we are also seeing a rise in serverless and managed services. These services promise to reduce the operational overhead of managing big data infrastructure. So it allows companies to focus more on business rather than maintaining the systems. And the last one is Dev DevOps. That means mixed with when you mix DevOps with data and machine learning, it becomes data ops and ML ops. So these approaches apply DevOps principles to data and machine learning workflows. The goal is to increase automation, improve quality, and reduce the time it takes to deploy new data pipelines on machine learning models. These trends are shaping the data engineering. They are creating exciting opportunities for data engineers to work with the cutting edge technologies and solve some of the complex or very complex problems. Now let's bring all of this with a practical example. So imagine you are a data engineer and you have been assigned a task. Your task is to create a simple data pipeline to analyze daily sales. Let's look at how you might approach this using Python, which is a popular language for data engineering. So here is the Python script that demonstrate a basic data engineering tasks. So if you are already aware with the coding, so the first and foremost, we need to import the libraries or the modules that we need in our program, right? So here when we work with the data, pandas is very important in Python. So here we have imported pandas, and then we are reading the CSV file. What kind of CSV file it is? It is daily sales file. So we first read the CSV file, that's the job, right? And then we perform basic transformations. We are calculating the total amount based on the quantity and the price. We are converting date. So there is something called to date time, wherein it helps us converting the string to date time format so that we can fetch month details. And the next line we are seeing the month, we are fetching the month details. And then we are grouping the month and we are grouping the data by month, and we are calculating total sales out of it. And finally, we are writing results to a new CSV file, right, which is monthly sales to CSV. We are converting it to monthly sales.csv. So now the monthly sales data has been generated. Like this is how we write a Python code. But coming to the data engineering, right, you might have seen here like we are implementing it under try and accept. So why are we doing this, right? So there are certain things that we need to take care of. So as a data engineer, we should be working as a software engineer plus data engineer, right? So we need to write code in such a way that it is able to handle any issues with the code. It is able to handle any issues with the data. It is able to handle any issues with the file. Hence, if we put it inside the try, and if there are any issues that we want to catch, if there are any error that we want to catch, right, any exceptions that we want to catch, we can catch it, or we can throw error, or based on that we can take certain steps. So that's all. So that brings us to the end of our introduction to the fundamentals of data engineering. So before we wrap up, I would like to thank you for joining me on this journey into the world of data engineering. If you find this video helpful and want to learn more about data engineering and AI and other exciting topics in the world of data, please hit that like and subscribe button. Consider subscribing and liking the notification bell. This way you will be the first to know when we release new videos in this series. We'll be diving deeper into SQL, Python, data pipelines, and much more in the coming week. If you have any questions about data engineering or the topics you would like us to cover in future videos, drop them in the comments below. Thank you again for watching. Happy data engineering. I will see you in the next video.